So before we really go into the solid mechanics part, for this video I'm going to give you some basic idea about how difficult the math covered in this course would be, as well as give you some introduction and the revision of the moment of inertia concept. So I believe, excuse me. So I believe most of you have learned general physics, and in that course it introduced mass moment of inertia. So what is mass moment of inertia? For example, you have a piece of object with the geometric center located here, and you have a differential mass dm located at the distance r from the geometric center. Then the moment of inertia generated by an axis passing through the geometric center. The axis is perpendicular to this plane, okay? Perpendicular to this plane. Assume it is a disk. So it is a disk, and for each differential mass located on this disk, it has its own distance r to the geometric center. Then the differential moment of inertia generated by each differential mass is given by r squared times dm. Then in case I want to find the moment of inertia of the whole piece of stuff, then you just do the integration. Then the moment of inertia will become, so you know that di equals to r squared dm, then the moment of inertia will just be integral of r squared dm. So it is the definition of moment of inertia. However, you might haven't heard about that in this world there are two kinds of moment of inertia. One is the first moment of inertia, and another one is the second moment of inertia. So for what we've learned from the general physics, it is called the second moment of inertia. So what are the difference between the first and second moment of inertia? So as you can see, this is the first moment of inertia. This is the second moment of inertia. Their formula are almost identical except the indice of the d terms. So it is d to the power 1, it is d to the power 2. At this moment you can see that, okay, first moment of inertia is something times d, and the second moment of inertia is something times d to the power 2. This is why we call it second or first. Next, how about area moment of inertia? Because in physics course we have learned about the mass moment of inertia. That means you times the mass with the distance square, right? But in this course we don't care about the mass moment of inertia. Instead, we will focus on the area moment of inertia. That is, we don't multiply the mass with the r square or the distance square. Okay, I call it distance. So I don't multiply the mass with the distance to the power 2. Instead, I times the area. For example, you have a large area and you have a geometric center. Then you have a differential area. So all the things are the same except the dm. So originally it is dm, right? So we just change it to dA. And this definition of moment of inertia is also work So next, let me give you some simple comparison. So on the left hand side, you can see it is a table of mass moment of inertia. So it is talking about, okay, in case, for example, this solid cylinder, it is rotating about an axis. So what will be the moment of inertia about this axis? Then the moment of inertia is given by this formula, I equals to 1/2 of mr squared. So you can see that it is multiplied by mass instead of area. However, for area moment of inertia, you can see that the moment of inertia is highly dependent on the geometry of a shape. For example, for this rectangular shape about an axis here, then the moment of inertia is dependent on both its width b and height d, height h.